Hey, Wire Monkeys, welcome to another episode of Let's Talk Cabling. On this episode, we're talking about MPTLs. What are they? How are they different? Welcome to the show where we tackle the tough questions submitted by installers, estimators, project managers, IT personnel, even customers. We are connecting at the human level so that we can connect the world. If you're watching this show on YouTube or listening to us on one of the audio podcast platforms, would you mind leaving us a rating and hitting the subscribe button? Those two simple little steps helps us take on the algorithm, which helps us educate, encourage, and enrich the lives of people in the ICT industry. Thursday night, 6 p.m. Eastern Standard Time. You know we do a live stream, right? Where you get to ask your favorite RCDD, and you know that's me, questions on installation, certification, project management, design, even career path questions. But I can hear you now. But Chuck, I'm driving my truck on Thursday at 6 p.m. I don't want to get into an accident. Gotcha. They are all recorded, and you can find them on letstalkcabling.com. And finally, while this show is free and will always remain free, if you find value in this content, would you mind clicking on that QR code right there where you can subscribe to the podcast? You can even buy me a cup of coffee or even schedule a 15-minute one-on-one call with me after hours, of course. And we're also always looking for corporate sponsorships. We got lots of great plans for 2024, and it's going to take some funding. So if you're a company who you'd like to sponsor this program and you're okay with being on an agnostic program that educates, encourages, and enriches the lives of people in the ICT industry, hit me up on social media. So as I said, one of the most common things that I see people confuse is MPTLs. What are they? How are they different from structured cable plant? And what's the right way to install, and what are your options for termination? So I brought on a very good friend of mine whom I've known for over a decade. Now, this individual is one of those people that I go to when I have questions. Welcome to the show, Dan Underbrink. Dan, how you doing today, my friend?
Doing great, thanks.
Yeah, we've known each other, what, 12 years, 13 years, something like
Yeah,
that?
something like that.
Yeah. And so for the audience, everybody loves to call me a subject matter expert. And I'll be the first to tell you, I'm not an expert. I go to people like Dan because Dan's the expert. He's the engineer. He's the guy that I go to with questions. And I've been getting a lot of questions about MPTLs. So before we get into the MPTLs conversation, why don't you introduce yourself, tell us who you are, who you work for, and give us a little background on you.
Well, I'm Dan Underbrink. I've been in the industry for about 45 years, 25 of it at Leviton. I'm a principal applications engineer, and I specialize in copper connectivity products.
What does a principal application engineer do for those who may not know?
Well, we do a lot of things. We touch just about every level in the manufacturing realm, and then also sales and customers. We do technical support. We sit on cross-functional product development teams and product sustainability teams, and we do training.
So you could be talking to like anybody from the apprentice on the street who's having a question about maybe a Leviton product or something, all the way up to the decision maker CEO of a company. Is that an accurate statement?
That's correct.
Man, you have to be really good at communication skills because that's two opposite ends of the spectrum. It truly is. And I know that you do training. I know that you're a fabulous trainer because I hear people commenting about your training all the time. So I want to talk about MPTLs. There's a lot, I surf a lot of social media sites, Facebook, Instagram, TikTok, and there's a lot of confusion about MPTLs. So the reason I asked you on, because I know that you have some experience with MPTLs. So can you give our listeners just a brief overview of what is an MPTL and how is it different from a regular structured cable run?
Sure. MPTL stands for Modular Plug Terminated Link, and that is a cabling link like a permanent link, except one end is terminated with a modular plug. Uh, when it's tested, it uses the same test parameters as the permanent link, uh, familiar permanent link that we find in TIA 568.
So where would somebody use an MPTL? I mean, I see a lot of people again in social media groups because not necessarily all of them are the best installers, or maybe some of them brand new. Quite often, I will see people say, "Well, let's just put a mod end on it. Why turn it on a patch panel? Just plug it right into the equipment." Would that be considered an MPTL?
Well, the usage of MPTL should be limited. It's not meant to run a cable to your desktop, put a modular plug on it, plug it into your laptop. That still requires a modular jack and a patch cord. So a modular plug terminated link is used for devices where it makes sense, like something that's in the ceiling, a wireless access point, a camera, a digital clock, some other device that's in the ceiling that's sort of permanent fixed, doesn't require being moved around very often.
So you said it really shouldn't be using at the desktop, and you mentioned that the desktop should be terminated on a jack. I mean, I kind of know why, but I want to hear the engineer's reason. Why is a jack better than an MPTL at a desktop application?
The permanent link is just that, it's permanent, and it basically goes typically from the jack in the telecommunications room in a patch panel to the jack in a wall plate at the desktop. So now you've got that fixed cabling that doesn't get moved around, doesn't get damaged. The patch cord connects it to your electronic device, and the patch cord is sort of the disposable piece that if it does get damaged, it's an easy fix. You just swap it out for another cord.
Excellent. That's I couldn't have stated that better myself.
Thanks.
Can you tell us what are some of the key components that you're going to be using when using NPTL that ensures their performance?
Well, it depends on what modular plug you're using, what level of craft you need to have. Uh, there are several different types of modular plugs, just a standard crimp on, and then there's the feed through crimp on, and then there's more of a circuit board type plug. And so the circuit board type plug is pretty foolproof from a termination standpoint, but it's often a lot larger than the input for your device can handle. So you always want to check and see if the plug is going to fit into your device. Um, the crimp-on plug is a little bit more difficult from a craft standpoint to get it on there correctly, and so it'll pass the test.
So when you say the crimp on, you're really talking about the mod end connector, right?
Right. The
Because that's what the trade calls. That's what the trade calls. I just want to make that connection for where the installer out in the field he may not know, that that's exactly what we're talking about.
Yeah, I'll also hear these called ice cubes.
Ice cubes. Yes, that's exactly
Yeah,
right. We have multiple names for everything in our industry, right?
that's
It's
correct.
like it's like learning, English. Is that New York City English, or is that Savannah, Georgia English, or is it California English, right? Because they're all different, but yet they're all still English. Saying our industry is weird with its names and stuff. So the ice cubes, the modular plugs, the crimp plugs, are they the best performing option, or are they the lowest performing option for that MPTL?
Well, there's different types of modular crimp plugs, and there's a whole gamut. Just the standard cheapest plug, uh, and what you have to do with that one is trim your wires to length before you put them into the plug. So that's a little bit difficult. You have to get that length almost perfect to get a good crimp. And then always for whatever plug you're choosing to crimp, you need to have the matching tool. There's a lot of problems associated with using the wrong tool with any given plug,
I would even add to that, even if it is the right tool, it's got to be in good condition.
right? You got to maintain the crimp die. Uh,
Right.
Yeah, so you always want to talk to the plug manufacturer about what their recommended tool is before you get started.
Right, because they are consumed. Those dies are consumables. They only last a certain number of crimps. And what'll happen is quite often with technicians is they'll buy that brand new crimper and it'll work fine on those first, 10, 15, 20 mod end connectors, but then all of a sudden it doesn't start crimping right. And they automatically just go blame the tool and then the connector. And it's, well, you know what? The tool has, it has adjustments to it. It's got to be kept clean, it's got to be kept oiled, and it's got to be kept in good condition. Otherwise, it's going to give you. That's why I think, and maybe you can confirm this, because does that look? Are those TDMs on your desk back there?
Yeah, very old ones,
Gotcha. So that's why they tell
1998.
us. There you go. So that I just bought the 15th edition at Bixie a couple weeks ago, and that's why they tell us that field terminated patch cords are not recommended. It's not that, again, it doesn't say you can't, but they're not recommended because of all those inherent issues.
Well,
I
that's
know you do
correct.
a lot.
It is really tough to build a patch cord from a piece of cable. Uh,
Right.
Number one, you're usually using a solid conductor cable, and most patch cords are made with stranded cable for flexibility reasons. So each time you crimp out a plug, it's got to be perfect. And that in the factory, we're looking at a quality plug, a matching die set recommended by the manufacturer of the plug, uh, and continual maintenance on everything to do with applying that plug to the cable. So you get a quality product, a guaranteed quality product every time with that process.
I know you do a lot of you deal with a lot of issues sent in by end users and technicians out in the field, and you have to determine what went wrong and stuff. Um, what are some problems that a technician should be careful with when terminating on a mod end connector?
Well, I would say like we were talking about before, there's different quality levels of mod connectors. There's one that you just put the wires in and crimp. There's others that have internal components that help hold the wires in place. If you don't have one of those more expensive plugs with the internal components, your craft techniques have to go way higher for the inexpensive plug. You've got to consider how the pairs are going to get crushed together when you crimp that plug with no internal components holding them apart. So when you take that prism crimp in the plug that goes down and grabs the jacket, first of all, you got to make sure the jacket's deep enough in the plug that that crimp hits the jacket. But even then, you can crush the pairs inside the jacket together and give yourself near and crosstalk problems.
Oh, absolutely. So you basically were describing the traditional mod plug. There's also one. There's a huge heated argument on between low voltage technicians in social media, pass through versus traditional. Right, the pass through is the kind where you actually literally pass the conductors all the way through, and then the crimper crimps the pins down and then cuts the ends off of it. What's your thoughts on the traditional versus the pass through?
Again, it's using the correct tool and it's tool maintenance. So on the traditional, you've got all the problems I was just talking about with crushing pairs together and making sure the jacket's far enough in. But you've got to have a really precision cut to length to get that plug on there properly. With the pass through, you've got a little bit easier situation because your length is going to be determined by where your tool cuts it off. So the conductors are passing through the plug, and again, you want to seat the jacket as deep as it will go into that plug. And Cat 5e and Cat 6 are different, by the way, on most plugs. So a plug is not just a plug; the category falls into the mix also. But when you crimp that, you want to be sure that the pairs are just in the best condition they can be. Uh, One thing I've found with the pass-through plug is so you strip your cable, you straighten your pairs out. If you position the pairs before you straighten them, you have much more success than if you straighten them and then try to drag the pairs into the position they need to be in, because you start affecting the pair lay down inside the jacket when you're moving the pairs around after untwisting.
Are let's go more deep on better options than the mod end connectors, because they're inherent with a lot of issues. Like you said, the tools got to be right, the technicians got to be skilled. What are let's go into more deep. What are some better options than those mod end connectors?
So for many manufacturers now, there are plugs with circuit boards in them that basically act like a jack. The jack has compensation, and these are typically what you find in a category 6A plug. The circuit board has compensation just like a jack circuit board has compensation to meet all the parameters it needs to meet for that high data speed.
Would the one with the circuit board inside of it, it's rated obviously to Cat 6A, and so is some mod end connectors. But we both know they can both be rated Cat 6A, but we both know that one can still be better than the other, right?
Yeah,
So which would be better?
I think you're going to have a very difficult time getting a crimp on Cat 6A that will pass Cat 6A. I mean, you might get it once in a while, but it's really difficult to get. The circuit board plugs have IDCs, and the cable punches down on them just like it does on a jack. Now, most of them are tool free. You just squeeze them together with your fingers. And also, if a plug says tool free, you don't want to be crushing on it with a pair of pliers. That'll cause problems.
Right.
So you want to use your fingers to close that plug down.
So I'm gonna play devil's advocate here, because I hear this all the time. Because I say the same thing. I mimic exactly what you say when I'm talking to technicians in the field. And usually the first question I get is, then how can manufacturers make a Category 6A patch cord?
So we're back to talking again about the quality of the plug used. Most Cat 6A patch cords that are factory made are not just your normal crimp-on plug. They look kind of like the normal crimp-on plug, but they've got internal components, often called load bars, that the pairs route around to hold them in place. Again, you've got controls over your tooling and over your processes, and you've got testing and measurement on everything. So quite a lot goes into a factory made cord to have it repeatable and available for category 6A data every time.
So when somebody in the factory setting is making patch cords, are they using the same crimper that somebody else has used, or do you guys have a buy a higher end crimper, or is there a specific machine that does patch cords? How does that actually work?
Well, there's usually a crimper. It can be a hand crimper, but it's a very expensive hand crimper with a very expensive die set in it. And that die set has a life. It's just like any manufacturing piece of equipment that you would do regular maintenance on. You've got a replacement cycle for that die set, so it only does a certain number of terminations. Now, debris could get down in that die, and if debris is in there, it can cause damage to the plastic. Damage to the plastic can cause connectivity problems. That's why there's inspection and testing on every factory made cord.
So do they track the number of crimps that they do in a factory setting on each die?
Yeah, they're either tracking the number of crimps or they're tracking the number of days that it's been in service.
I guarantee you, technicians not doing that in the field. I guarantee it.
Right.
And then they'll wonder why it's not crimping right, because they've been using the same Radio Shack crimper they bought 22 years ago. Just saying, right? Another area where I usually run into some confusion. I've had people on the show talk about this on previous episodes, but they've always been test manufacturer companies. But I want you're a manufacturer, right? When somebody's testing MPTLs, they're going to be submitting to you for warranty. What is the correct way to test it, and why is it important to test that way?
Okay, so before we had MPTL, uh, people would put plugs on cable, and we called it direct attach. And the only way they really had to test it was to put a channel adapter on one end of their test set and a permanent link adapter on the other end. Um, the problem with a channel adapter is it's manufactured to test channels, and channels include the cable and the patch cords, everything except the plug at both ends. And when we're doing an MPTL, the plug crimp is the thing we're the most concerned with. So the channel adapter doesn't actually accurately measure the noise of your crimped on plug. So when MPTL was developed, there's some specific testing requirements, and that is to use a patch cord adapter on your tester, and it has to be the same category as the plug that you're testing. So you put a patch cord adapter on one end of the tester, permanent link adapter on the other end of the tester. You select MPTL from the tester menu, and it runs it, and it applies the same test parameters that it applies for a permanent link.
Let me ask you this, because you're manufacturing, you guys have a warranty program, right? And you have contractors working that warranty program. Let's say, and we both know that they're always hiring new technicians, new apprentices, and stuff like that. If somebody doesn't know the correct way to test an MPTL, and they test, I don't know, all the wireless access points doing a channel test, would that affect the warranty on those particular drops?
Yeah, we would not be able to warrant those drops on the basis of those tests. And that's the reason we have a certified contractor program and provide training on this so that contractors don't get into these kind of pickles.
So if they did it that way, pretty much, I guess you would say, well, we're not going to warranty this until you go back and retest it the right way. Is that an
Correct,
accurate statement?
correct.
Yeah. As a former estimator, I can tell you right now, building up estimates, they only put enough time in there to test that cable once,
Yeah,
not
that wasn't built
twice.
in. That wasn't built into
Right.
the budget. So it's a
No.
mistake as a contractor you don't want to make.
Right, right, right. What are some of the common failures and misconceptions that you've seen with people when it comes to talking about MPTLs?
Comments like, well, it always used to pass when we did it with channel adapter. Now it doesn't pass. It just shows a basic misunderstanding of the function of a channel adapter versus the function of a patch cord adapter. The patch cord adapter is actually measuring the quality of your crimp or of your plug end.
Another thing I hear quite often when talks about people crimping patch cords, and I've tested this myself and proved that it's not right, but I want to hear your thoughts on it. They'll say, well, it doesn't matter what colors go where as long as they're the same on both sides. Well, my opinion is that's true as long as it's either A on both sides or B on both sides. But if you start at
Correct.
the white blue on one side and end up the brown white on the other side and do the same thing on both sides, that's not going to pass the test because you're splitting up the pairs where the
Right.
where the computer's expecting for them to land.
The protocol is looking for twisted pairs in certain areas, and that's why we have T568A and T568B wiring methods. People wiring straight through, they'll call it straight through, just pin 1 through 8, wire 1 through 8. That's not going to work.
No, it's not. It's going to give you all kinds of problems. Let me ask you this: which performs better, T568A or T568B?
Well, they're they're both pretty much the same, but it's not going to perform at all unless you have it the same on both ends.
Right. Yeah, I've had people ask that. They say, well, we do B because it performs better. I'm like, no, no. I got bored one Saturday, and I sat up in my new studio that I'm working on, and I took a piece of cable, I cut it off, I terminated A, tested it, terminated a B, tested it, and I compared the two test results, and they were nearly identical. Now
Yeah,
the A did perform a tiny bit better, but I couldn't attribute that to maybe I terminated that one a little better than the B. But I mean, the difference was not even enough to even worry about. Where
right.
do you typically see your T568A customers? What kind of customers like the A wiring scheme?
Well, A wiring goes a lot to historical. So historically, Canada used A wiring, and although today there's a lot of movement toward B wiring, in the U.S. when A and B wiring came into existence, there was some traditional wiring that had been in place that exactly matched the B wiring. So in the US commercially, we went with B wiring. Now in the home, it tends to be A wiring, and the reason for that is pair 1 and pair 2 on the plug exactly matches pair 1 and pair 2 on the 6-position plug. So if you apply a dial tone to pair 1 and pair 2, plug a 6-position plug into your 8-position jack, you'll pick up dial tone on those first 2 pairs if it's
Exactly
A
right.
wired.
It's backwards compatible with it. Yeah. And I want to make sure I clarify this because I know somebody's listening to this. There's a lot of confusion between pin 1 and pin 2 and pair 1 and pair 2, right?
Right.
Because pin 1 and 2 is the orange or the green pair, depending on which wiring scheme it is. Pair 1, which is the blue pair, is pins 4 and 5 in the middle of the jack.
That's
So
correct.
a lot of people get confused about it. So I want to make sure I clarify that somebody who might just start listening to the program recently, and they say they heard you say pair 1 and they thought, they're thinking pin 1. There's a difference between pin 1 and pair 1. Huge difference. Ask me how I learned that. Oh, there's a story behind that one, I tell you. Dan, it's been a pleasure having you on the show, my friend, and you are a wealth of knowledge. Just keep doing what you do and keep inspiring people like me out there in the field, man, because you are the cat's meow when I have questions. Obviously, like I said, I go to you because you are very meticulous and very thorough in everything that you do. I've seen some of your reports. I'm telling you, I looked at that and I was like, wow, I don't know if I can came up with that detail. So that concludes tonight's show. I certainly hope that you found it enlightening as much as I have, because like I said, this is one of the most confused areas of our industry. Till next time, remember, knowledge is power.
That's it for this episode of today's podcast. We hope you were able to learn something. Make sure to subscribe so you don't miss out on future content. Also, leave a rating so we can help even more people learn about telecommunications. Until next time, be safe.